An educator wants to determine whether a new curriculum significantly improves standardized test scores for third grade students. She takes a sample of 80 students using the old curriculum and finds that 61 passed the test. She takes a sample of 76 students using the new curriculum and finds that 62 passed the test. Test whether the proportion of passing students is greater at a level of significance 0.1. Alright, so is it one population or two populations? It's two populations. Is it a means problem or a proportions problem? It's a proportions problem. Next, is it a chapter 7 problem or a chapter 8 problem? It's a chapter 8 problem. Alright, so okay, sorry. So let's write down what data we have. So we have two groups, group 1 and group 2. So N1 students, that means group 1 is the old curriculum, and among them we have 61 success. For group 2 the sample size is 76. Among them we have 62 success. Alright, so that's our data. What's our hypothesis? So it's a two populations proportions problem. So we should be dealing with P1 minus P2. Now, our claim is like group 2 is the new curriculum people. So for group 2, like P2 should be higher. We are looking at proportions of students which passed. So the new curriculum should be improving the scores. That means 62 should pass the test. That means more should pass the test. So P2 should be bigger, which means this should be like negative, and this 0. Now, test statistic. So this one's slightly difficult. So for chapter 8, 2 sample proportions, this is the formula. So let's calculate these things one by one. So P1 hat is R1 by N1, which means 61 by 80, 0.7625. Alright, P2 hat shall be R2 by N2, (62 by 76), so 0.8158. Alright. There is another thing which is P bar. So which is R1 plus R2 by N1 plus N2. So P bar, which is R1 plus R2 divided by N1 plus N2, which means 61 plus 62 divided by 80 plus 76. So 0.7885. Alright. Finally, we have the test statistic, which is Z equals this formula. You should be very careful about the use of brackets. You don't need to use it too much and not too little. So we on the top is p1 hat minus p2 hat divided by square root of this whole thing. So which is like p bar 0.7885 times 1 minus p bar 0.1 minus 0.7885 times 1 by n1 plus 1 by n2. 1 by 80 plus 1 by 76. Alright, so we just have to put the square root here. So it's minus 1.81. I'm sorry, it's minus 0.81. Alright, so let's go to the rejection region obviously now. So we should start drawing by a Z. Okay, it's a left tail test. So there should be a ZC here. And the left tail is the rejection region. How fat is the tail? The tail is 0.1 fat. So go to the Z table and look for 0.1. Alright, so 0.1 lies between this number and this number, which is minus 1.28 and minus 1.29. So minus 1.285. So if Z less than ZC, reject HO. Does that happen for us? No. For us, minus 0.81 is actually bigger than ZC equals minus 1.285. So we fail to reject HO. This implies we fail to reject HO, which means, alright, so we fail to reject HO means we have failed to prove HA, which means we have failed to prove that the new curriculum improves score. So that's our conclusion. We have failed to prove that the new curriculum improves score.